Today, Americans only receive 53% of the internet speed that they pay for. And according to the FCC, the internet of today will not become the internet of the future. There is no migration path. Why? Because we're still using the same dial-up technology that was in dial-up modems 30 years ago. It's called Ethernet, and it is fundamentally flawed. My company, Ether2, fixes the problem. Our product, the Q, is the solution. The Q eliminates bottlenecks by eliminating routers. The Q could be wired or wireless, fixed or mobile, star or mesh. Internet protocol stays exactly the same, and the Q accepts legacy Ethernet devices, providing a seamless migration path to the future. The larger the network and the more bursty the traffic, the better the Q will perform in terms of real broadcasting, quality of service, latency, throughput, and battery life. Today, we are launching our technology to the open source community because this technological breakthrough is much bigger than we are. So cast your demo God vote for the only fundamental change that will affect every company presenting here today. The Q will strengthen national security, solve net neutrality, and close the digital divide. Thank you.
We don't use broadcast very well. We take a broadcast radio channel like the 802.11 Wi-Fi and we turn it into a point-to-point link. We don't actually recognize in the protocol sense that when you radiate over the radio, multiple sites may actually hear the same data. Or if you're radiating from a satellite, if you had the right protocols, you could take advantage of the fact that hundreds of thousands or millions of receivers get the same information. We just don't have protocols to do that, even though the underlying communication system is capable of delivering that service.
To measure physical activity, we have pilot tested the use of a 2-gram wireless accelerometer, which can measure acceleration in 3 axes. Thus far, we have successfully used this accelerometer to measure physical activity in 11 infants. Here you can see an infant in our study being monitored in his isolette in the NICU. There are 5 accelerometers total, 1 on each wrist and ankle, and a 5th on his hat. We have also used this accelerometer system to measure activity in older infants. As you can see, we are able to monitor the activity of this infant wirelessly.
So as a background, let me remind you that the current internet infrastructure is largely driven by the large ISPs who are heavily reliant on the high-end router vendors. So it's not a surprise that the infrastructure is centered on expensive routers running proprietary software. And because the providers can't control the forwarding path of the routers that they own, the pace of innovation is quite slow. So what's going to change this? What new is going to happen? Well, there's a new class of network. These are networks that are connecting huge data centers. Think of Amazon and Google. These new wide area networks, I'll call them WANs, are, in terms of the bits carried on the backbone, at least as large as the Tier 1 ISPs. So they're very large networks, and they're growing very rapidly. So what makes them different? Why would that cause a problem? Well, the reason why they're different is because they're run by cheapskates. That these companies refuse to buy expensive hardware or support proprietary software. So remember what these data center companies did for data center computing. They took a market that was dominated by high-end server vendors, and they turned it into commodity x86 boxes and open source software. And they have decided they're going to do exactly the same thing for the WANs. So their goal is an infrastructure around low-cost commodity routers and switches built around Broadcom or Fulcrum chips or other vendors, and open source software to control those boxes. Whether it's a centralized control or a distributed control in the routers themselves is immaterial to this point. So it's open source software control and commodity boxes.